So now we'll be taking a quick look at standard form. And what is standard form? So standard form, a number is written in standard form when it is written as 8 times 10 raised by n, where a is between 1 and 10 and n is an integer. So what does it mean? Standard form is just a standard way of representing numbers, and I'll show you what I mean. For example, if I write the number 5,000 and I write it as 5 times 10 raised by 3. Normally, you know that these two numbers are equal because 10 raised by 3 is 1,000 and 1,000 times 5 gives you 5,000. But writing this number in this form is called standard form. This form in which you have written this number is referred to as the standard form. So this is the standard form of 5,000. And how do we know it's the standard form? Because it must be in this form, and we see that that form states that a times 10 raised by n. And what are the conditions? A must be between 1 and 10, and as you can see, 5 lies between 1 and 10. Similarly, n must be an integer. Integer means whole number like 1, 2, 3, minus 1, minus 5. Those are integers, and n is an integer. So now let's look at another example. Is 7.15 times 10 raised by minus 3 in standard form? Now we ask ourselves, the number there is 7.15. Does it lie between 1 and 10? The answer is yes. And is minus 3 an integer? The answer is yes. So this is what in standard form. How about 0.72 times 10 raised by 5? Is this in standard form? So we ask ourselves, the number that is there, does it lie between 1 and 10? And the answer is no. 0.72 is less than 1, even though the integer, there's an integer as the exponent. But since one of the conditions is not satisfied, this number is not between 1 and 10, this is not in standard form. So standard form does not just mean multiplying a number by 10 raised to the power an integer. Take note that the number that I am multiplying, this number here, must be between 1 and 10. So how do we write numbers in standard form? That's what we're talking about now. So how to express numbers in standard form. So let's start with this. Here we have 7 million. So let's try to solve this. Now you have 7 million. So now I want to write it in a form of a times 10 raised by n, and I want a to be a number between 1 and 10 and n to be an integer. So now the decimal point in 7 million lies here. So where can I shift the decimal points to in this number, in which I will have a number that is between 1 and 10? So now if I shift the decimal place to this point here, I'm going to have 7,000, which is not what I want. But if I shift it to this point here, I'm going to have 7.000, which is equals to a 7. So I can have a whole number that is between 1 and 10, which is 7 times. And now that I've shifted the decimal point here, I'll ask myself, how many times did I move that decimal point? So I moved it from here to here. So I count the number of steps I took. So you count it like this. You move it. This is the first step, 1. Then you came to this point, 2. Then you moved it here, 3. You moved it here, 4. You moved it here, 5. And finally you moved it to this position, 6. So you moved it 6 times. So the exponent here, n, will be equals to what? 6. So 7 million is the same thing as 7 times 10 raised by 6. And I should mention that when you are moving towards the left hand side, when you are moving from right to left, then the exponent is going to be positive. So now let's try out this. Now decimal point is here. So where can I move it to, in which I will have a number that is between 7 and 10? Obviously, if I move it here, I'm going to have 57.655, which is greater than 10. So I can only move it here. And when I move it here, what am I left with as a number? My new number becomes 5.7655. So times 10 raised by what? How many times did I move this decimal point? So that is what I just have to count. I moved it from here to here. So that will be what? 1, 2, 3, 4. I moved it 4 times. So 4.7655 times 10 raised by 4. And also let's look at this in which the decimal point is here, but I want to move it to a point in which I have a number between 1 and 10, and the only point I can move it to is this point over here, because when I move it here I have 1.24577, so I can write that out. I have 1.24577 then times 10 to the power of, how many times did I move the decimal point from here to here? I just have to count. So I moved it 1, 2, 3. I moved it twice, so that will be twice. So the reason why the exponents are positive in this case is because I was moving my decimal point from the right towards the left direction. But let's look at some examples in which I will have to move towards the right direction. So now I want to express this number in standard form. Now this number is clearly less than 1, but how do I move the decimal point in such a way that this number falls between 1 and 10? So I have to move it from this point to this point. When I moved it to this point, then I have number 006, which is the same thing as 6. So I have 6 times 10 is power. Now how many times did I move the decimal point? I moved it 1 and I moved it twice. I moved it twice. But now since I'm moving towards the right direction now, the right, then I will add a negative to the exponent, to 6 times 10 to the power of minus 2. So now let's try to solve this. I will have to move the decimal point from here, not towards here, because if I move it here I will have 67.8, which is not what I want. So I have to move it from here to here. When I move it here now I will have 66.78, which is between 1 and 10. So I have 6.78 times 10 to the power of, how many times did I move towards the right direction? I'll have to count. That will be 1, 2, 3, 4. I move 4 times, and since I'm moving towards the right, that will be minus 4. And let's do this final example to quickly recap. So in this case, to move it to a number between 1 and 10, I have to move the decimal point from here to this point. So what am I left with? I'm left with 1.23789, then times 10 to the power of, how many times did I move it here? 1, 2. I moved it twice and I moved it towards the left direction. So the exponent here is going to be positive, positive 2. Let me make it visible. I moved it twice, 1, 2. So now let's try to solve some questions or examples that are extracted from JAMB past questions. So as you will see from here, most of the questions you'll be given might not be pretty straightforward, but if you understand the concept, then it will be really easy to tackle. So here we are told to express the product of this and this in standard form. So product means to multiply. So they ask us to multiply 0.21 by 0.34. But now we are told to write our result in standard form. So now when you take your calculator, or if you walk through this or you punch in your calculator and you multiply these two numbers, what you will get is 0.0714. And once you have gotten 0.0714, the question is now, how do I write this in standard form? So to write it in standard form, as we've been discussing, what is the goal? The goal is to have a number that is between 1 and 10, and that means I have to shift the decimal point from here towards here, so that when I shift it here I'll have 7.14, which is between 1 and 10. So I have 7.14, then times 10 to the power of, how many times did I shift it? I shifted it 2 times. 1, 2. I shifted it twice, and I shifted it in the right direction. And remember, if you are shifting towards the right direction, the exponent is going to carry a negative sign. So this will be what? 10 to the power of what? Minus 2. So which option corresponds to that? 7.14 times 10 to the power of minus 2, which is C. So the answer to this question is C. Pretty straightforward, right? Yeah, it's actually very easy to tackle. Now this is the last question that I'll be talking about. And this question, now we are told to divide these two numbers. This over this is equals to k times 10 raised by n, where n is a whole number. The values of k and n are, so now what this means is that this expression you have to solve it and to express it in standard form. But the question is not asking you to tell them the answer in standard form. Instead, you have to tell them what the k value is and the n value is. So first, we need to express this in standard form. If you look at this question now, it might be impossible to type this into your normal calculator or on-screen calculator because the digits are too long. So you have to first simplify before you can solve it. So how do we do this? First, let's write these two numbers in standard form. So the first one, I need to shift the digits decimal point from here to this point here. So I can have a number 1.432, which is between 1 and 10. So that will be 1.432 times 10 to the power of, how many places did I move it? I moved it 1, 2, 3, 4. I moved it 4 times. That will be times 10 to the power of 4. And also, I do the same for the denominator, in which I need to move, my decimal point is here initially, but I need to move it from here towards here so I can have a number between 1 and 10. So I have 1.94 times 10. Oh, and sorry, there's a mistake here. I was moving towards the right direction, so there is meant to be a negative sign in the exponent. Yeah, there's a negative, so 10 raised power minus 4. In this case, how many places am I moving? So I'm moving it from here 1, 2, 3, 4, 5, 6. I'm moving it 6 places, and since I'm moving towards the left, then it's going to be positive. So I have this. So now I can separate this. This is the same as writing 1.732 over 1.94 times 10 to the power of minus 4 over 10 to the power of 6. Now you can easily type this into your calculator, and when you type this in to 3 decimal places, your answer you are going to get is, or 4 decimal places, is going to be 0.7381 to 4 decimal places. So now, if you remember, I can write this as what? 10 raised power minus 4, then divided by 10 raised power 6. Now, if you remember from our law of indices, when you have two numbers that have the same base, but their exponents, they have the same base, and there's a division between them, what do you do to their exponent? You subtract it. So this is same thing as writing 0.7381 times 10 to the power of minus 4, then minus, there is plus 6, so minus 6. So this is same thing as writing 0.7381 times 10 raised power minus 10. Now I will ask you an important question. Is this in standard form? And the answer is no. And why is that? Because this number here is not between 1 and 10. It is less than 1. So what do? I need to write it in a form that it is between 1 and 10. So that means I have to move the decimal place from this point to this point. And when I do that, I'm going to have 7.381 times 10 raised power. Now I moved it how many points? Just one place towards the right, so there's going to be a negative 1 since I moved it once, then times 10 raised power minus 10. So similarly, applying the law of indices again, when there's a multiplication and the base are the same, what do I do to the exponent? I sum them up. So this is same as saying 7.381 times 10 to the power of minus 1 plus minus 10. And I know that minus times plus is minus. So this is same as saying 7.381 times 10 raised power minus 1 minus 10. And that is equal to 7.381 times 10 raised power minus 11. So now, as you can see, is this in standard form now? Yes, because this number is between 1 and 10, and this number here is an integer. But the question asks us to just identify the value of k and n. So we see what k corresponds to, and we see what n corresponds to. So our k is what? 7.381, and our n is what? Minus 11. So k is 7.381 and n is minus 11. So what option corresponds to that? And that will be option A. So the answer to this question is A. So now, as you can see, writing numbers in standard form is pretty straightforward. just that in the questions you might be given in JAMB, it might not be direct. You have to do some mathematical operations like addition, subtraction, multiplication before you will be asked to express the numbers in standard form. But once you understand the basic idea, then solving it becomes really easy. So this pretty much sums up all you need to know with regards to standard form.